Today's seminar is going to cover square roots. The standard that we're looking under is understand, apply, and communicate the number system. And our I can for today, or our goal is, I can evaluate and estimate square roots. So by the end of this lesson, I'm hoping that you are moving towards accomplishing this I can statement here. So in front of you, you should have your square root notes that were handed out. And just a couple of things here. Once again, the standard that we're looking at is up top, and our I can statement is here at the top of your page. Now remember, this note sheet you can put in your notebook and refer to whenever you're working with square roots. So to start off today, before we actually get into working with square roots, we have to have some background knowledge here. So we first want to look at perfect squares. Oh, what is that? Well, the definition here is a number that is the square of an integer. Now, if we're squaring something, we're multiplying it by itself. I will do examples on a separate sheet of paper, but you can absolutely fit your examples right here on this first box up here, where we're looking at perfect squares. So let's talk about some perfect squares. Now, these are numbers that are multiplied by themselves. So we can think of certain numbers like, if we did, let's start with 5. So a square, remember, is 5 to the exponent of 2. And that exponent tells us that we're going to multiply 5 by itself. So we'll have, this should be equal to 5 times 5, which is equal to 25. Similarly, you could do something like 3 squared, which is 3 times 3, and that's 9. So when we're squaring something, we're multiplying it by itself. And you could absolutely do something like, if you had a negative 4 squared, you'd have negative 4 times negative 4, and that would give us a positive 16. Now with squaring negative numbers, it's important that you have the parentheses around them. Otherwise, your answer will be negative, because technically there would be a negative 1 multiplied in front of the 4 squared. In following order of operations, we'd do 4 squared and then multiply by negative 1. So if you want the positive, you have to make sure that you have the parentheses there. So these are our perfect squares, and this is going to set us up for learning about square roots. So I would copy these examples, remember again, to this top part of your page here. And just as a side note, I'll be providing you with a list of squares and square roots. So as you can see here, we have perfect squares all the way through 30. And it would be beneficial to commit to memory at least your square roots through your squares and square roots through 25, as these will pop up in the future and you don't want to have to calculate or search for them. They're things that you can commit to memory. So let's take a look at square roots then. And our definition of a square root is the inverse of squaring a number. So if we think back to our perfect squares that we had, if we want the inverse of what we found here, remember we're doing the opposite thing, so we're going back to where we started. So let's look at this example of 5 squared. So if I said I wanted the square root of 25, remember this is not a division symbol, that's your root symbol. So a square root of 25. Really what this is telling me is that I have a square with the area of 25 units. So I have my 25 units in that square, and we're finding the inverse. So how did we get to this 25? What led us to that? Well, here is where we have to look at the sides of our square. So here, or here. We're looking at the side lengths of what we did to get this 25. Well, this is 5, and this is 5. And remember again, 5 squared was 25. So if we want the square root of 25, we want to go back to where we started. So a square root of 25 would be 5 because of this here, what we squared in order to get to 25. We're doing that inverse operation, kind of like subtraction is the inverse of addition, and subtraction is the inverse of addition, and division is the inverse of multiplication. Same type of deal here. We're trying to see where we started. So we can absolutely do this with any other number that's a perfect square. So these ones that we're looking at currently are perfect squares. So if we look at the square root of 16, so if I had a square with the area of 16, I'm finding what are the side lengths of this square, and those lead me to the square root of 16. Where did I start? Where was my root? You can think of it kind of like a tree. They start at the roots. So at the beginning, what did we do first? Well, we had 4 and 4. Well, 4 squared gives me 16, so the square root of 16 must be 4. Now sometimes you might encounter something where the negative is out front of your square root. Now what this means is that this square root here, or this root of 36, is multiplied by a negative 1. So really what this looks like is negative 1 times the root of 36. Well, if we think about what did we multiply by itself, what did we square to get 36, we would get 6. And we need to multiply that by negative 1, which would give us a negative 6. So be conscious of those problems that do involve negative answers, and make sure that you do keep that negative with it, because this is what's happening, and this is what that means there. So those are a few examples that you can be writing down. Other times, you might see a square root that is a fraction. So something like, let's say 225 over 25. Now this looks confusing at first, but the best thing to do here is to say square root of 225 over the square root of 25. Now you might be wondering, why can I do that? Well, since this fraction is underneath this radical here, or this root symbol, radical is another name for it, it's telling you want the square root of 225 divided by the square root of 25. So if we separate this into two separate steps here, we can work with this. Now we can figure out what this is exactly. So the square root of 225, and you can refer to your chart, you do have this. So if I'm looking, square root of 225, down here, is 15. So I can go here and write 15. The division symbol stays, and the square root of 5, you can refer to your sheet, but this is one you might know already, is 5. So we'll write our 5 there. Now, you must always make sure that these are in simplest form. So 15 divided by 5 would be 3. So our final answer here is, of course, 3. Now, the same rule with the negatives can apply with these ones as well. So if you have a negative out in front of your root symbol. So let's do something like, let's do like 9 over 4. And this will equal the square root of 9 over the square root of 4. Now this negative, this has to stay, and I'm going to put it with the numerator. Typically, if your negative is out front, it's going to go with the numerator when you're dealing with fractions. So, square root of 9, remember your sheet here, we're trying to do the inverse. So what did we square to get 9? We squared 3. So if we have the square root of 9, if we're doing the inverse operation, we would get back to 3. So I should have 3 over square root of 4 is 2, because we squared 2 to get 4. And this does need to stay negative. So your answer here would be negative 3/2. This one I don't need to reduce any further. This is as small as it can go. These ones you can keep in fraction form. Just make sure that they're completely reduced. So those are some examples that you can have written down on your example sheet. If you ran out of room, you can absolutely put them on the back. So on this purple sheet here that you have then, you should have this part filled out, this part filled out. Now let's take a peek at the bottom. So estimating a square root to the nearest tenth. You're also asked to do this to the hundredths place in ALEKS, but the process is the same here. So we have a few steps that we need to follow, and I will be going over those here in a second. So we're going to need an example, and once again I'll do this on a separate sheet so it's bigger. Make sure that you are writing down your examples here though, and if you run out of room, you can do it on the back. So for this one, we're going to look at a square root that doesn't have a perfect square. Now most roots are going to be like this because not every number has a whole number that can be multiplied by itself to get to that number that's under the root or the radical. So we have to do some estimating in order to figure that out. So I think the one we're going to look at right now is, let's say we have the square root of 60. So we don't have a number here that can be multiplied by itself or squared to get 60 exactly. So our first step in this process is to look at our sheet here. It says pick a perfect square below and above the given number, and this will tell you the two numbers that our answer will fall between. So using the less than symbols here, I'm going to set this up on this sheet. So in the middle would be root 60. We have our less than on both sides. And what I need to do is pick a square that's exactly below, or the one closest that's below, and the one closest that's above. So if I'm looking at my sheet, and I'm looking, where would 60 fall? It would fall between 49 and 64. So on my sheet here, the lower one would be the square root of 49, and my upper one would be the square root of 64. And this will ultimately tell me which whole numbers that my answer will fall between. So if I look here, square root of 49 is 7, square root of 64 is 8. So that means that my answer, so this is 7, this is still root 60 because we haven't figured that out yet, and root 64 is 8. So we know that our answer needs to fall between 7 and 8. So on your purple sheet, we've done step 1 here. Now step 2 asks you to list the tenths values that fall between the two numbers you found in step 1. So we're going to list all the tenths. And what I mean by that is we would look at 7.1, 7.2, 7.3, 7.4, all the way to 7.9. So we're going to use these to try and figure out what gets us closest to 60. Now, looking at all 9 of these, that would be a lot of multiplication. So a quick trick here, and I did list it on your sheet, is to look at your middle answer and decide which one is it closer to. Is this closer to 49? Is 60 closer to 49? Is it closer to 64? Well, it looks to me that it's closer to 64, so I probably want to use numbers that are higher up here in the when you're looking at the tenths. And what you need to do is square those or multiply it by itself and find which one gets us closest to 60. So I think I'm going to start with 7.6 because it is closer to 64. I'm going to start with higher numbers up here. 7.1, 7.2, these ones down here are going to be closer to this 49. And we want to get as close to what the answer for 60 is as possible. So 7.6 times 7.6. So you have to work through your multiplication here. So 6 times 6 is 36. Bring your 3. 6 times 7, 42. So give me 45. Remember, you need your 0 here because we're moving up a value. So you need that 0. 7 times 6 is 42. We need our 4. 7 times 7 is 49. 49 plus 4 would be 53. So 6, 7, 7, and 5. Now we have 2 numbers that are behind the decimal. So that means we need to move the decimal place 2 from the right side of your number, 1, 2. So 57.76. Now that's pretty close, but I think I can get closer than that. We're still about 2 away from this answer. So I think I'm going to skip 7.7 and go right to 7.8 and see what that does. So 8 times 8 is 64, 6, 56, so that'd be 62. Bring your 0, because we moved a place value, we need that 0. 7 times 8 is 56, 5, so 49 plus 5 would be 54. 4, 2 plus 6 is 8, 6 plus 4 is 10, put a 1. Okay. Now, this is a little bit above 60. It's actually 84 hundredths above 60, so we might be close here, but I want to try 7.7 just to be sure. So we want to see which one is closer. Which one is ever closest is your answer. So, I'm just going to try this quick. 49, put your 4, this would be 54, or I'm sorry, 53. 7 times 7 is 49, plus 4 would be 53. Bring your 0, and 7 times 7 is 49 again. We'll use the same 4 and get 53. 9, 3 plus 9 is 12, 5 is 6, 59.29. Remember, 2 numbers behind the decimals, so we have to move it back twice, 1, 2. 59.29. And remember, we're rounding to the 10th, so I guess technically this would have been 60.8, and this one is 59.3. 7.6 is too far away. It was just a starting point for me. I'm not going to use that one. So we have to look at both of these and think, well, which one's closer? 60.8 is actually 8 tenths away from 60, whereas 59.3 is 7 tenths away from 60. So technically this is closer. So if we estimated this square root for the square root of 60, we would estimate that the answer to the 10th would be, if you think back down here, it would be 7.7. And the same thing would happen if you were estimating to the hundredths. You would just start maybe with the tenth and then start adding a hundredth to it. So starting with a tenth and then adding your hundredths to it in order to figure out what it would be estimated to the hundredths place value. Just as a quick check, let's just use my calculator quick. And let's take, I don't like that light on there, let's take the square root of 60 and see what we get. 7.7, so if I'm looking at this here, this 4 would not round the 7 up looking at the hundredths. So 7.7 would be our answer to the 10th. And that's exactly what we found by just doing multiplication or squaring these numbers. Remember, multiplying by itself is the same as squaring. So this will be the process that you'll use to estimate square roots. So thinking back, we would find a square root that's a perfect square on the lower side and the upper side, figure out what two whole numbers your answer would be between, write out your tenths, decide if it's closer to the higher number or the lower number, and then start doing multiplying and start figuring out what your closest answer is. And that would be estimating a square root. So today we've worked through square roots. Remember, the standard we were looking for was understand, apply, and communicate the number system. And our I can statement for today is I can evaluate and estimate square roots. So hopefully after watching this, you can confidently say that you can do this, or you may be thinking, well, I'm working towards accomplishing this. If you have any questions, please feel free to ask me.